Hello! So in this video we're going to start talking about these things called cubics. What on earth are they? But before we do, I want to talk about these things called polynomials, because if you understand what one of these is, you'll understand a cubic. So polynomial is just a function, all right? And it's a function where we've just got y on one side, all right? And a bunch of stuff involving x on the other side. Now, when we say that we've got y on one side and a bunch of stuff involving x on the other, we simply say that it's y in terms of x, or y as a function of x. Okay, so what I'm going to do is I'm going to write y on one side and then a bunch of x's all on the other side. So I'm going to have x, I'm just going to add a load of x's for the time being, but I'm going to do something with them in a minute. So x plus x plus x, what have I got, plus x, oops, plus x, and do you know what, I'm bored. So I want to just carry this on forever and ever and ever. This is what these three dots mean. It just means carry on forever and ever and ever in the same way. Okay, then what I'm going to do is I'm going to look at the powers of x, and I'm going to start with x to the power of 0. And then all I'm going to do with the next one is increase it by 1. So I'm going to have x to the power of 1. Then the next one, increase it by 1 again, so I'm going to have x to the power of 2. And then I'm going to have x to the power of 3. And then I'm going to have x to the power of 4. And then finally x to the power of 5, and then x to the power of 6, and 7, and 8, and 9, and so on, all the way to infinity. But what I can also do is put numbers in front of all these x's. It's getting exciting, isn't it? So I'm going to put a number here, and 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 then I think, hang on a minute, they're letters, they're not numbers. You don't need any kind of qualifications in maths to know that. But you see, the thing is, all I'm talking about here is a very general thing called a polynomial. I'm just talking very generally. If I say, well, in front of x to the power of 0, I can only have a 3, or in front of x to the power of 1, I can only have a 2, or whatever, suddenly I'm talking very specifically. I want to talk generally. So what I'm saying there is I'm just going to have a load of numbers in front of each of these, in front of each of these x's, okay? Don't know what the numbers are, so I'm just going to call them letters. Why not? Also, the numbers in front of the x's are called coefficients. They're just the things being multiplied. So for example, in this case, A is a coefficient, B is a coefficient, C, D, E, etc. They're all coefficients. Okay, I can do a little bit of simplification though. Ax to the power of 0, that first term up there. What's x to the power of 0? Well, anything to the power of 0 is just 1, isn't it? So in other words, I've got A times 1, so that's just A. All right, so this first term is actually just A, okay? What about this bx to the power of 1 then? Well, x to the power of 1, that's just x, isn't it? How many x have I got? I've only got one of them, and I'm multiplying it by b, so I'm just going to have bx. All right, what about cx squared and dx cubed and all the rest? Well, I can't really do anything with them, okay? So this is kind of the best which I can get it. So this up here, this is a general form of a polynomial. Now, the thing is, there is a little bit more to it than that, and okay, there's really kind of formal mathematical definitions, which we don't need to worry about, because this definition is perfectly fine for me, and it's perfectly fine for you, and for what you need. Okay, so let me just write down an example then. So y is equal to 3 plus 4x plus x squared. Hang on a minute, there's no number in front of that x squared. Oops. Yes, there is. Okay, plus 0x cubed. Well, hang on a minute, 0x cubed. 0 times anything, that's just 0, isn't it? So in other words, I'm not going to have an x cubed term, okay, plus 5x to the power 4, plus, and then so on and so on and so on, all the way to infinity. Don't worry about that. So this would be a perfectly good example of a polynomial. Okay, now I'm going to try and put some language with these things called polynomials to actually sort of enable me to talk about them, okay? And specifically, I'm going to talk about the order or the degree, okay? It means the same thing, order, degree, literally the same thing of a polynomial. And all it is it's just the highest power, okay? It's just the highest power of a polynomial. Let's get rid of that. It's meant to be an exclamation mark. Highest power of the polynomial, that is the order of the degree. Hang on a minute. This thing carries on forever and ever and ever. These are what these three dots mean. So how can it be that, you know, why are we talking about the highest power? Surely it's going to be infinity. Well, not necessarily, because look, if let's say, for example, I have a 0 here, okay, so I've got 0x cubed, that's why I didn't write this in. I have a 0 here, and then everything after that all goes to 0, okay, so every other coefficient after the x squared term is 0, effectively. Then basically, anything times 0 is just nothing, so I'm just going to have a bunch of zeros being added together. That's all going to disappear. Don't have to worry about it. Okay, so in other words, the polynomial is going to finish after that one there, or after that one there, sorry. So in other words, the highest power of this polynomial would be 2, because that's the highest power. Remember, there's an x to the power of 0 there and an x to the power of 1 there. So the highest power is just 2. So I can say that the order, or the degree, of that polynomial is just 2. Hang on a minute, if I write that in another order, if I write that in the reverse order, flip it round, so y is equal to, I've got x squared, 1x squared is 1, right? Sorry, that's just x squared. So x squared plus 4x plus 3. Whoa, hang on a minute. Isn't that quadratic? So I've got a quadratic going on. So a quadratic is just a special type of polynomial, and it's of order 2. The degree of the polynomial is of order 2. That's a quadratic, order 2. And actually there's some other ones that we've met before as well. So if I just kind of have this, okay, so this is like a summary, if you like. This is our formal kind of general polynomial that we've just come up with, okay. Well, a constant, okay, is just a number, right? So y being just some number, that would be described as a constant function. So in other words, we only get as far as the a term in the polynomial, okay? And that order will be, well, what would the order be? Remember, there's an x to the power of 0 hiding in there. Okay, so the order of that would be 0. If I wanted to draw that on a graph, it would just be a straight line. I'm drawing the graph, but trust me, there's a reason why. Okay, a linear. Well, that's of the form y equals mx plus c, right? So we can just have a plus bx. In other words, it's just 1x going on in there. So in other words, with a linear polynomial, a linear function is just an example of a polynomial of order 1, okay? Because we only get as far as the bx term, okay? And that would just be a straight line, something that looks like this, okay? A quadratic, what we've just discussed there, we go a plus bx plus cx squared. We only get as far as the cx squared term. Okay, so the third term in the polynomial, and that would be of order 2. That's the highest power, so degree, order, same thing, okay? And of course, we know that that looks something like that. It's a parabola. Oops, my head's in the way. Okay, a cubic then. I wonder what a cubic could be. Well, we've just had a plus bx plus cx squared. A cubic would just be getting as far as the dx cubed term, the x cubed term. And a cubic is of order 3. Cubic, cube, get it? Okay, now I've got to move out the way here, because a cubic would look something like that. Oops, I'll stand up actually. So a cubic would look something like that. Now the reason why I've kind of discussed the orders here, so if I actually move over a little bit more, the reason why I've talked about the orders, why is that important when it comes to polynomials? Well, the order tells me how many times it crosses the x-axis, because look, if we look at a constant, one up there, that one up there, okay, how many times does it cross the x-axis? Well, it doesn't. It's just a flat line. It doesn't cross the x-axis at all. What about a linear? Well, a linear crosses once. It crosses there, all right? What about a quadratic? So I'll move out the way slightly. Well, a quadratic crosses the x-axis twice. It crosses there and there. What's the order again? 2. So a constant doesn't cross the x-axis at all, so the order is 0. The linear only crosses once. The quadratic only crosses twice. There's a relationship between the order and the number of times it crosses the x-axis. And fairly obviously with a cubic, we can carry on going. That's 1, 2. The order of a cubic is 3, and it crosses the x-axis 3 times.